So welcome, everybody, to Where the Land Meets the Sea. I wrote far too many notes here as introduction, and I'm going to skim through this because I need to give the speakers a chance, right? But thank you, James, for leaping at this suggestion of this series. And it's great to be collaborating with the coalition, too. I think this is the... Yep. I believe this is the first time that the Whaling Museum and the Buzzards Bay Coalition has actually collaborated on a series. So that's very special. There are lots of people to thank who helped out at the museum: Christina, Connette, Stephanie Moran, Arthur Moto, Melanie Correa, and others. And the coalition, Rob Hancock. Where's Rob? Hi. And Alicia and still others. I really want to extend a warm welcome to the speakers. I think most of them came from next door, but I know that Steve came from further away. And I think the opportunity tonight is to hear straight from the horse's mouth about the top carrot takers of our bay. So thank you for participating. Now, slide. Okay, there we go. So the problem is that we really should worry about the fish, and finally our species, I think, is beginning to. And this theme is what we're going to hear about tonight, which is restoring rivers and estuaries, native fish and shellfish. So our first speaker is John Kachmar. He's the Nature Conservancy's Coastal Program Director. This is such a flimsy thing. And John is responsible for statewide coastal conservation and restoration work, as well as regional efforts from Cape Cod to Long Island Sound. He's going to fill us in on the Nature Conservancy's recently launched SouthCoast Shellfish Restoration Project, quite ambitious, which is to restore 5,000 acres of native shellfish species. John told me that he grew up on a beach in Connecticut where he spent a lot of time swimming, sailing, fishing, and that gave him a lasting appreciation for the ocean. In 2011, Sara Quintal became Buzzards Bay Coalition restoration ecologist. She's another speaker, and she has extensive experience in wetlands assessment and permitting, invasive species mapping, ecological restoration. And she's going to tell us today, give us details about the coalition's Acushnet River Restoration Project, which she directs, and how an abandoned lumber yard has been transformed into a 19-acre park that will open this summer. What's really cool is that Sara, where's Sara? There you are. Sara grew up right up the street from where this project has unfolded. She told me that this project was one of the reasons that she went to the coalition, so she could bring about a positive change close to where she played as a child. Third speaker is Steve Hurley, and he has been the Southeast District Fisheries Manager for the Mass Division of Fish and Wildlife since 1990. In recent years, one of his special interests has been coastal brook trout populations, and he's going to describe the Red Brook Trout Restoration Project, which is, and its goal of restoring one of the few remaining salter trout streams in eastern Massachusetts. And he grew up trout fishing at his grandparents' place in New Hampshire, and this is a big reason for his desire to restore and maintain trout habitat today. So we're going to end up with a panel discussion, and led by Tom Gidwitz, who's a longtime board member of the BBC, served as chair for the board from 2010 to 2013. He's a veteran science writer, has written a number of magazine articles, and currently working on a book devoted to his longtime interests of archaeology and volcanoes. Tom actually went camping and hiking a lot as a child in the North Woods of Minnesota, and describes that as the reason why he's committed to issues related to the environment today. One last profile to leave with you is Buzzards Bay itself and its watershed. Basically, the Buzzards Bay is roughly 228 square miles. The watershed around it is much larger at 435 square miles. And Buzzards Bay itself is referred to as a fairly large estuary, i.e. a place where fresh water mixes with seawater. The watershed itself is composed of many smaller estuaries that occur at the mouths of rivers and streams. There's so much more to say about this profile. I'm going to leave it out, but there's a lot of reason to be optimistic these days. And one reason that might not occur to you, it didn't occur to me, is that our watershed is pretty small compared to other watersheds. The rivers around the watershed are on the short side, so the headlands of the watershed are no more than about 10 miles out. And because this is a smaller area, it's easier to manage. So there are reasons to be hopeful, and I'm now going to turn this over to John Kachmar. Thank you.
So I'm going to talk to you about shellfish today, what the Conservancy and partners, including the coalition and others with several municipalities that we've been working with in Massachusetts and more specifically and more recently in Buzzards Bay about our initiative here and our thoughts here. I showed a scallop here, a bay scallop up here. I'm really not going to talk about bay scallops, but they're always hard to not talk about. They're just an incredible animal in terms of really being iconic to Buzzards Bay. So it's hard to talk about shellfish in Buzzards Bay and not show a scallop. So this might be your only opportunity. You may not want to ask me a lot of questions about scallops because I don't work with them, but we are going to start working them a little bit, and I'll explain that. For people who aren't familiar with scallops, if you see the blue dots on the lower mantle, those are essentially eyes. They have up to 30 or 40 blue eyes. They're not quite like our eyes, but they see light differences. Just a really neat organism, obviously filter a lot of water, and as I said, really iconic to this part of the world in terms of bay scallops. These are the inshore scallops versus the offshore scallops. So just to talk a little bit about why we would want to restore shellfish, what they offer. We think of these as services we get from shellfish, and there are many of them. I've named a few here. Really, when we think about oysters, for example, by the way, I'm primarily going to talk about oysters, a little bit of scallops at the end, but when I'm talking about shellfish restoration, I'm really talking about oyster restoration. In the photo here, you see what might be a native oyster bed with some other species, ribbed mussels in this case, commingled in that. So this is the sort of habitat that we're looking to restore. We've lost about 85% of this habitat globally, and a lot of people don't think of oyster reefs as a habitat, but they are, and they're a very endangered habitat. That 85% is pretty conservative. We've probably lost more than that in many places, and New England is no different. They filter, each individual oyster filters upwards of 50 gallons a day of water, so they're incredible filter feeders. They can provide storm protection by acting as a reef, by slowing water. Certainly there's recreational and cultural activity around fishing for them. And they're a wholesome food source for us, for people that may fish them, and also lots of wildlife, birds, other animals supporting finfish, which live above reefs, some of them having commercial value. I feel like I skipped a slide. I'm going to go back here quickly. No, I didn't. So just a little bit about one value that I want to talk briefly about that's really a lot of interest in this, and this is the ability of shellfish to reduce nutrients in water. Everybody's probably heard that we have nutrient problems, excess nitrogen in our coastal waters that's driving algal blooms and depressing various habitats of all sources and diminishing the overall productivity. Oysters can sequester nitrogen because they utilize it. They bury it in the ground. Where the wild oyster bed is what's really important, and that's what this slide is really getting at. As you look at the types of denitrification and the value, you're seeing that the various pounds, upwards of 0.4 ton, these are actually tons, on a project in Great Bay. I'm just giving you as an example, and the top is what's being denitrified, being gassed off. That's what happens on wild beds. And essentially, in the mud, the oysters are denitrifying through a chemical process and gassing it off and making it inert so that it's removing a lot of it. Also in the shell and the meat, also sequester some, but not a whole lot. 0.02 we're looking here. And then in addition to gassing off, they can bury nutrients in the sediment. They actually hold it in the sediment. So this just gives you an idea. All the numbers don't matter. We shouldn't overinflate this taking care of our problem of excess nutrients, but it's an important part of the picture that should be factored in, whether it's aquaculture grown in cages or whether it's wild oyster beds. Just as an example, here's the 85% gone I mentioned, food and fish for birds and crabs, and clearly recreational fishing. When we talk about oyster reefs, these are sometimes hard to envision because we don't have a lot of them left anymore. So and this is true globally, there are some places in the Pacific Northwest, in New Zealand, in places where there are extensive beds where people would be more familiar. On the left is a photo of a project that we were involved with years ago with Mass Audubon on Lieutenant's Island in Wellfleet, if people are familiar with that. This was a demonstration project. You can see these clumps look like they were placed, and there's actually concrete structures below those. All of those oysters attached to that naturally with what was in the water wild and attached to that. This is a very small demonstration. On the right, I've put an example. Don't think that this is necessarily a Massachusetts scenario. I just wanted to give you an example of a very robust reef that can actually have 3 dimensions. It gives you an idea of the habitat. And you can imagine at higher tides, this is a lower tide, this would be covered with fish and crabs and species eating, getting protection from predators, all sorts of activity in that. So just to give you an idea of what these might look like. So our vision for Massachusetts and thinking statewide is this big goal of trying to restore what we think is a missing 5,000 acres statewide of oyster habitat. This is the best we can tell for what we might reconstruct from what we had historically and what we might get in the future. And it's very hard to tell, but this is really based on thinking about the 5 embayments of the North Shore, Greater Boston, the South Shore, the Cape and Islands, and of course Buzzards Bay. And roughly 1,000 acres is what we think is missing for these oyster reefs. We're hopeful to work with other organizations, with municipalities, to do this collectively. This is not something the Nature Conservancy can do by ourselves, and we have no hopes that we would be able to do it, but we think collectively by 2050 maybe we'll get there. We're really focused on doing 10 demonstration projects. We have undertaken projects in Wellfleet. As I mentioned, I showed you that picture with Mass Audubon we worked with. In 2013, we did a project in Martha's Vineyard, and we're planning a project in Fairhaven in Buzzards Bay this coming summer. It's really already underway. Most of the work doing shellfish restoration, which I'll talk about what that entails, is before anything actually goes in the water. The in the water part is very, very short, and the less time consuming, it's all leading up to that in terms of planning and permitting and various other work associated with it. So what do we do to restore shellfish beds? we really have to start out with some foundation because oysters swim in a larval form and they like to attach to something hard. They need to attach to something hard or they actually die. And so we're substrate limited in many, certainly in the Northeast and in many areas where we don't have enough hard substrate compared to what we had historically. So we need to enhance this, and we typically use clamshell and create a foundation. You see on the left, we're actually bucketing a large amount of shell out of a dump truck. This is a video that unfortunately doesn't work. I'm going to try one more time, but I don't think it'll work. There's sound, but there's no... Yeah, sorry. Shut that off because that's kind of annoying. So they're taking it out of this truck. They're loading it on a barge, which you can't see in the video. The barge is right up on the beach. In the center is the barge. It's in fish totes. It's full of shell. And on the right, we're actually taking those and putting them over the side in a fairly strategic manner in order to build some structure on the bottom that has some elevation to it, because we need to get some elevation off the bottom and get things out of the sediment in order for oysters to survive on that. And then once we've put down the shell, about 100 cubic yards per acre, somewhere in that neighborhood, which is a fair amount of shell if people are familiar with a cubic yard, 3 feet by 3 feet by 3 feet, 100 of those or so. We need to seed it because we're lacking seed in terms of having enough wild production, because we don't have a lot of oyster reef left, that we actually need to seed it. We get seed in the hatchery. We place it on some sort of shell. In the upper right, you see a scallop shell with juveniles that have been seeded on it. This is for work we did in Martha's Vineyard. On the left, you see some of our interns who are bagging that shell in order to bring it to the hatchery and get it placed on. And then that spat-on shell gets put onto the foundation we put down of the clamshell. You see in the lower right, there's a picture. There was a video. I was going to fly you through one of these locations, but unfortunately can't because it doesn't seem to be working. We've also been trying to figure out what are the natural recruitments like for oysters in Buzzards Bay in particular. This is an example that we've been working on the coalition, and actually Sara's really headed this work up over the last few years to try to get some understanding how much wild spat is actually swimming around in the water in a larval stage and then actually connects. So in the upper right, you see a custom spat collector that we had made locally here in New Bedford, actually by Kachmar Traps. It's really a mini lobster trap that has Home Depot 12 by 12 tiles suspended in it. And the oysters, as well as many other organisms that Sara can attest to, some we want and some we don't want, really gives us an idea to quantify how many oysters are setting in these areas. And we've placed these in some locations in Buzzards Bay on a limited scale. We're looking at Nascatucket Bay and Fairhaven, where we're planning to do work this summer in June and July. And this just gives us an idea. Do we have a robust natural recruitment? Is this a good place to try to establish a bed? Will it perpetuate, self-perpetuate? And certainly in Nascatucket Bay, we've seen some of the best results of anywhere we've been looking. That is, it seems like pretty consistent over the last 3 years, oyster juveniles being recruited in this area. Let's see if this one works. Nope. I apologize, this isn't how I wanted to show this, but you get the idea. We've been thinking on a statewide perspective, how do we think about where we want to do oyster restoration? One of the reasons we've landed in Buzzards Bay as a real focus area is because historically this is a very important place for oysters, as well as other shellfish such as scallop. And we know that this is a place that we should be doing restoration from an ecological perspective, and also have a lot of interest with organizations and municipalities that know a lot about shellfish in order to help with this. So this is some of the siting criteria. We want to know where's their hard bottom naturally. We want to know what depths are like. We want to know historically some of those patterns you see. are where there historically were shellfish by species. So we've done this statewide, and we can then zoom in wherever we want to do that. This is an example in Marshfield, happens to be the North River, to look a little finer scale. Is this a place we would want to do an oyster reef restoration based on depth, historic presence of species? Is there hard bottom? In this particular case, we're not seeing a lot of hard bottom because we'd see a lot of blue dots. The red dots are somewhere in the middle of hard bottom. So we've been working quite a bit at the Conservancy to put this data together in order to determine where we should be working. So really our approach has been rebuilding shellfish beds for the ecological value. Remember all the services I suggested they offer? We really want to put back a missing habitat. We want to restore that 85% plus that's lost because they're very important ecologically, as well as providing nutrient reduction and wave attenuation and all these other services. We're just missing the habitat. And we know that they're very important for recreational and commercial fishing. Oysters a little less so for commercial because we're getting so efficient at growing them in cages, and everyone can attest to that who's been eating these incredible oysters that we're getting from Massachusetts and Buzzards Bay and other places. And then, as I said, the secondary benefits, nitrogen reduction, water filtration, those sorts of things. So more specifically in Buzzards Bay, we're on the cusp, starting with Fairhaven this June and July in the water, of undertaking oyster bed and both bay scallop restoration work. We'll do at least 4 projects. I suspect we'll do more because we'll probably get really incredible in-kind from the towns, and it makes it cheaper to do these projects. But at least 4 oyster restoration projects and 1 multi-year bay scallop restoration. Bay scallops are a little bit different. They're free swimming. They don't attach. We're planning to do those in cages so that they would get more juveniles in the water and reproduce in the water and get a jump start by creating a caged sanctuary, if you will, of organisms. Probably out in the islands is the places we've been looking because that's where we tend to find the larger spawning populations of bay scallops and conditions for that. As I said, culch and spat on shell for oysters caged. We'll be working with the Buzzards Bay Coalition, the Bouchard Trustees, which is an oil spill, which folks are probably familiar with, happened about 12 years ago, providing funding for lots of good stuff in this part of the world in Buzzards Bay. And of course, the towns, when it comes to shellfish, are critically important because the towns really control shellfish resources in Massachusetts. The towns decide how they want to do it, where they want to do it, what they want to grow, all those sorts of things. So they're really critical and actually have the authority with oversight from the Division of Marine Fisheries for this sort of work. And that's it. There's contact information there. Thank you.
Hello, thanks everyone for coming out tonight. And I think everyone can hear me? Good. All right, this is the only snowy picture I am going to show today. This is our Acushnet River Restoration Site. I am longing for the days when I can see green out there again. But I want to walk you through what the problem revolving around river impairment is. Rivers worldwide suffer from a myriad of impairments resulting from development, industrialization, and agriculture. And some of those impacts range from the full-out filling of floodplains and wetlands to development right on the riverbanks, the resultant chemicals, garbage, and sewage that come from us humans being here on the earth with these resources, and we don't always take very good care of them. Physical barriers are another problem. So in addition to anything that might be in the water itself, barriers also have their own issues, namely because they really mess up the natural flow of water that's coming down a river or a stream. And they trap sediments behind them, as well as prevent wildlife passage from going back and forth, namely fish. Fish like river herring, eel, salmon, they utilize both the freshwater parts of the rivers as well as our bays in order to complete their life cycle. So river herring in particular, particularly this time of year, you have alewife blueback herring that spend much of their time in the bay waters, but they don't spawn there. They return to the freshwater rivers where they were born in order to lay their eggs. And dams prevent them from being able to do this. So we've seen over the past couple of hundred years the effects of dams on these fish populations. Nationwide, some estimates are that there are roughly 66,000 dams on our rivers. Only about 2,500 of those are used for hydropower. Others are used for irrigation, flood control, or recreation. But the main reason why so many dams were put in the first place was before we had nuclear power plants or coal-fired plants, people needed electricity. They needed to power mills. And so dams were the way of creating this early form of electricity. But as technologies evolved, these dams became obsolete, but yet their infrastructure remained. So they became scars, essentially, on these river systems. No one needed to maintain these dams for the most part once they were able to get electricity from other sources. So a lot of these dams fell into disrepair, became unsafe, and their scars continued. They perpetuated in the ways that I described, with preventing wildlife from being able to pass and continuing to alter the natural flow of water. Here in Buzzards Bay, we have 7 major rivers that wind their way into the bay waters. So as Anne mentions, we have a relatively small watershed, but all of that land that does drain into Buzzards Bay still has an impact and still all interconnected with the bay. And the Acushnet River is one of those rivers. And I've got a red arrow pointing to where the Acushnet River is in relation to the bay. So our urban river has seen its own fair share of impairment. Dams have been recorded on this river as early as the 1700s. The natural banks of the river were developed in order to make way for the building of textile mills, which the city of Bedford is well renowned for. We also had a myriad of other industries: whaling, fishing, metalwork. And with that comes population, which brings sewage. And so we have been seeing the effect of this industrialization on our riverway, which is New Bedford Harbor. Acushnet River starts up in the New Bedford Reservoir. Many people don't realize that Lake Street, a spot that many local folks have gone fishing to as a child, that's actually part of the Acushnet River. It's impounded, but it is one and the same, and those waters that flow from the headwaters up at Lake Street flow down through this Acushnet River property that we're going to be talking about tonight and into New Bedford Harbor and then out into Buzzards Bay. And the sewage problems have been around for a while. Dating back to 1870, there was a lawsuit brought against the city by Edward Haskell because he claimed that the amount of raw sewage that accumulated at the end of his dock was so bad that it had horrid odor and restricted boat access. He was successful in winning his lawsuit. So even well before the Clean Water Act, people were noticing that things weren't being managed very well. From the mid-1900s on, we still had our fair share of issues that we're grappling with here on the river and New Bedford Harbor. Industrial waste primarily. In 1982, PCBs were the one on everyone's mind, and the Superfund site in New Bedford Harbor was declared by EPA. Many of us have been hearing the ongoing projections of how long the PCB cleanup will take. It's not an easy solution, and it's one that we're continuing to, we're hoping to see the end of it sometime in the near future. But that's not the only fix that we need to do on our harbor to restore the river. We also have issues with combined sewer overflows and stormwater runoff. But we have a vision for how we can restore this river. And the Buzzards Bay Coalition, which has been around for a quarter of a century now, definitely saw the potential in this resource. The portion of the river that's shown here is stretching from just below I-195 in downtown New Bedford up towards Keith's Tree Farm, so just below that Lake Street area. And so this is a good snapshot that shows the tidal portion of the river that gets inundated daily by the tide, and where it narrows is where it churns fresh. So part of our vision on how we could restore the resources associated with this major river of Buzzards Bay involved protecting any land that hadn't already been developed and trying to create opportunities where some of those lands could be restored and their ecological resources improved. The other thing that not just the coalition but our other partners have also been thinking about is how we can bring people back to the river to enjoy this resource that many of us have not been able to get up close and personal with in a very long time because of the pollution. And there's been this series of pocket parks that are becoming established along the banks of the river that we think can become connected via a trail. Acushnet River Trail is one name that has been thrown around. The city of New Bedford, the town of Fairhaven, the town of Acushnet, the coalition, as well as Serped, have been sitting down and talking about ways in which this trail could connect all of these properties, and the red and the yellow on this map are some of those possible locations. And the Acushnet sawmill is just at the very tip of that red, the very north part of that red, and it would sort of serve as this north anchor for this trail system. There's many benefits of protecting natural lands, which most of you probably are already familiar with, filtering pollutants being among the top of the list. But improvements in in-stream habitat and fish passage is certainly at the foremost of our minds. And protecting these natural resources, what's left of them, and improving the resources that are there and have potential for being restored are all important things that we should be striving for the benefit of biodiversity, recreation, aesthetics, but also what some other folks might argue, the most important things, the local economy, the regional fishing industry, and tourism. They're all interconnected. This is a view looking downstream from the freshwater part of the Acushnet River towards New Bedford Harbor, and then you can see it opening up into Buzzards Bay. There is one big thing that jumps out at you when you're looking at this aerial, namely how white the right-hand side of the photo is. That's the dense urban concrete pavement, urban components of the city of New Bedford, and on the left side are the communities of Fairhaven and Acushnet, which have much more green to them. The other thing that you can notice as well is that particularly along New Bedford Harbor, just where it starts to open out, there's this lighter green color that are the marshes that still exist. Fortunately, not every bit of natural wetland was filled in along the banks of New Bedford Harbor, and part of what the coalition's been working on is trying to make sure that any bits that are left aren't developed and that they're permanently protected. The Acushnet sawmill is circled there in yellow, so that's what I'm going to be talking about in further detail. So it's a 19-acre site that is at the very head of tide, and it's got a long history. The first dam being built circa 1738, and it's been a variety of mills over the years, from sawmills to grist mills to a wool carding mill, paper, cotton, and most recently sawmill from the late 1800s through the 1900s. The sawmill lumber treatment or the sawing of actual lumber ended around the 1950s, but the site was still seeing other forms of industry. Namely, there was a hardware store, which many people remember. That hardware store had its fair share of fires as well and ultimately closed in the 1980s. And then the site supported other light industrial type uses. But there's a lot of big names that used to own this property at one time or another, including good old Charles Morgan. The coalition purchased the property in 2007. And, excuse me, the site is outlined here in red. And one thing to notice is that there's an awful lot of trees that were on this 19-acre property. It came with a lot of forest and field that was on it. It had a few acres of pavement and buildings as well. But what the coalition saw in its vision for protecting the Acushnet River, it saw in this property particularly the opportunity to protect the site from getting built out with more condos or something else. And because the river runs right through the middle of it, it had a really good potential for reconnecting people with the river. And the really interesting thing about this property is it's just above the PCB contamination. The dam is getting pointed to here with the arrow. That dam had a lot of ecological impact in the sense that there were many fish that weren't able to get up above that barrier, but by some tokens as well, it probably prevented to a certain degree some of that PCB contamination from going farther upriver. And once we took ownership of this site, the timing worked out in the sense that we were a willing landowner that enabled a really great fish passage success story to unfold. NOAA had really spearheaded the effort in order to address this dam that was preventing our migratory fish from being able to access their freshwater spawning grounds. The full dam, it wasn't completely removed, but much of it was removed, and a natural rock fishway was put in. And these fishways, or these ramps, I sort of equate to stairs that help you get from the first floor of your home to the second floor. They're a way that makes passage possible. And this fishway was finalized in 2008, and almost immediately we started seeing the benefits to fish. This shouldn't be confused with a fish ladder. There's all sorts of different ways that fish passage can be constructed. And in this particular way, it's considered a nature-like fishway that best resembles the natural river channel, short of fully taking out the dam. But it did have a very dilapidated old rickety ladder associated with it that enabled a measly 400 fish to be able to get up before the restoration. Once that dam was taken out, every year we started seeing the numbers of those herring increase. And the estimate last year was over 10,000 fish. So we saw a 27-fold increase from prior to the restoration. And then we knew there was a big vision for this site. So with this first piece complete, what we considered sort of the centerpiece of the property complete, it was time to put into action the restoration of the rest of the site. And this is the concept for that site-wide restoration. And the light green areas around the edges, as I pointed out in that other aerial, are the existing forest and wetlands. And then the yellow is the fields, and really the expansion of the existing fields that were there, and connecting a myriad of restored habitats with a network of trails that incorporated overlooks and even a canoe launch. Here is one rendition of how that vision was going to play out. On the upper left was a photograph that was taken from a bucket truck. I think Tally has been in this bucket truck. I know Tally's in this room. There's been a couple of us who have been sent up in a bucket in order to take really cool photos of this site pre and post restoration. I am not happy to say I had to go in that bucket, but we do get some incredible photos. And this one on the left is one of those that shows the main entrance to the property. Namely, there's a pretty big building that was just torn down a couple of years ago, and closer in the foreground are the remnants of a concrete foundation that was the hardware store. On the lower right was what we had wanted the park to ultimately look like, meaning all of the big industrial buildings gone and being able to see the river from the road. That's a novel idea. And fields and forests that led down to it. So in order to do this, there was a lot that had to happen. It took us a full year of permitting in order to get all the approvals necessary. But with New Bedford Harbor Trustee Council funding, we were able to hire an engineering firm to do that concept design and then put together the design plans to get us through permitting and into construction. And we had a lot of partners along the way, one of which was the city of New Bedford, who was our primary demolition contractor for getting up acres of asphalt and concrete. And that's what you're seeing in this photo. And in the top right, there was only one building that we hung on to, and it was not a historic building, but I guess an antique reproduction. It's a post and beam building that you're seeing behind this bulldozer that just had a lot of character to it, and we thought could make a pretty good visitor center when everything was said and done on this site. So we ended up salvaging that building and building a new foundation for it. And what you're seeing is the building being moved and set down onto that new foundation on the bottom photo. And we basically recycled whatever we could out here, which included some really great granite blocks that you'll see in another picture shortly down the road, and a lot of lumber from invasive trees that had to get taken down. We were able to cut those trees into usable sizes and ship them up to Gurney's sawmill in Freetown, and they milled them into lumber that then got used for boardwalks throughout the property. January 2014 is when the real fun started. We got to use even more big machinery to do the critical river work, where we were able to really release this river from these concrete walls that have been holding it back for a couple of hundred years, and able to restore the floodplain wetlands that would have been there before the site got filled for industry. Sumco Eco-Contracting was who was doing all this work. So here is a view taken from the main bridge that was on the property. This is a view of the fill and the concrete being taken down. And that is what it looked like as of November. It hasn't been very photogenic without all that snow. So I'm just itching to get back out there and take some better photos that will have a little more green in them, probably this summer, how it's looking. And this is looking downstream from the site from another bridge on the property that shows these granite blocks that made up part of that channelized river wall. Those are the granite blocks that we were able to salvage and reuse for an amphitheater that you will see. But what you're really noticing here is that we went from having very straight, tight river walls infringing on this river to bringing those walls down and restoring a nice gradual slope along both sides. And with that, we're restoring the vegetation that fish will hide in along the edges, that birds will come and roost in and feed in. And also we're restoring natural floodplain protection by increasing the width of this channel. When we do have really big storms, this site can now absorb much of that impact first before that water goes further downstream. And this is another good look at what some of those concrete river walls looked like and what it looked like afterwards. Because we do have active fish in this river channel, we weren't able to do work all year long in the river. So we had to be very careful about timing when machinery was going to be in the water and taking down these walls. But the result looks pretty nice, I'd say. So this is looking up from the head of tide at the south end of the property, and you can see the relocated building that will be our visitor center, and how those channel walls, those concrete walls, are gone. And we were able to create quite a bit of wetland out there as well, about 1.3 acres or so of wetland, 1 acre of which was a created swamp that was right where you're seeing that building. It was a parking lot before, and we ripped up all that pavement and started digging down to intercept groundwater, created all sorts of pools and variable elevations in the swamp, brought in a lot of trees, a lot of shrubs, and turned into something that looks like this. All of this green and the water that you're seeing, that was a parking lot just a few short months before. And some of those reused timbers from some of the trees that did have to come down were used in the boardwalks that you're seeing on the left side there. And we created about 1/3 of an acre of marsh along the side of the riverway that's above the fishway. Here's what it looked like once we were starting to lay out the plants that were going to be filling in this marsh. And then this is what I kind of like to refer to as the car sales lot picture of the marsh. Once we put in all of these great plants, which included some shrubs and a lot of small little tubulings, Canada geese became our worst enemy. They're infamous for liking to taste everything, particularly if you spent a lot of time agonizing over what to plant, where to put it, and getting it in the ground. They could decimate this restoration area of the restoration project just by going over there and tasting and pulling them out by the roots shortly after putting them in. So how we take care of that and keep them out is by stringing a lot of string and flashing tape to basically scare them away. I'm looking forward to taking that off of our beautiful vegetation this spring. And in another part along the river, where we did have quite a bit of trees already, the issue there in this part of the floodplain was that we had a whole lot of opportunistic trees that are not native to the Northeast. And trees as well as a lot of invasive shrubs and vines like bittersweet and multiflora rose. And it was just so far gone past the point of return that we really did have to essentially start from scratch in order to try and bring back a native woodland ecosystem. So we did, and this is part of what you're seeing here is the planting of new trees and a new slope. So this part of the property is, you can see it from Mill Road as you're driving by the site. And to connect all of these wonderful habitats that were getting restored, we put in nature trails and overlooks like these two. And the trails throughout much of the site, certainly the western part of the site, are all handicap accessible and baby carriage accessible. I've heard a lot of people who are itching to get a kayak in this river, and the canoe launch that is shown on the upper left-hand side will make that possible. This will give us access to the freshwater parts of the Acushnet River. Maybe not so much in the summer when water levels get really shallow with drought, but certainly in the spring and fall. It's going to be gorgeous to kayak over here. And then, can anyone pick out what might have been reused in the lower right? Anyone? I heard granite blocks. So we used them for seats in an amphitheater that we cannot wait to use for outdoor education programs. You can fit about 60 kids in this amphitheater, plus a few adults. But I think it'll be a great spot where anyone was going to be able to come and have a visit, have lunch, enjoy lunch, and overlook the Acushnet River, which is no longer constrained to this tiny concrete channel. Some of the helpers along the way, particularly for our visitor center, included the local technical high schools, Old Colony, Regional, as well as Greater New Bedford Voc. They've really been involved in this visitor center restoration every step of the way, from the measuring out of the building that we were saving, figuring out exactly what its dimensions were, getting it drawn onto a site plan, and doing the design for its refurbishment, including adding on an addition for the ever-important bathrooms. We're excited to not have to have a porta potty long-term. But then the really exciting stuff is that it goes from drawings in the classroom to real-world application. These students have been involved in every aspect of the foundation installation to putting in the beams that you're seeing here that would support the building once it was sat on top, and doing the carpentry, the electrical, and the plumbing. They've been working on this project all last year and through this winter, and it's looking like we'll be done this May, and they're doing a fantastic job. They were not exempt from the cold. They've been working on this through all sorts of inclement weather. And it's coming a long way. It's really coming out great. Myriad of partners that this project would not have been possible without. But I want to leave you with a short video. It's a 3-minute video that was put together by Tom Richardson of New England Boating. And got to do a little shuffling over here. But Tom came out last year and put together this great video that was released in November that I think will give you a good feel for the site, which is slated to be open, weather permitting, hopefully by later this summer.
Hi, Tom Richardson for New England Boating, and today I'm coming to you from the site of the former Acushnet River Sawmill a few miles from New Bedford Harbor. Now, since 2007, the Buzzards Bay Coalition and its partners have been working hard to restore this site and make it into a public park where people can come and kayak and canoe and fish, also wander around the trails that wind through the property. And to tell us about those restoration efforts and the future of this park is Rob Hancock of the Buzzards Bay Coalition.
What we've created here is a canoe and kayak launch where people can bring their boat and get out and access the Acushnet River and paddle up, look at foliage, to look at animals and other wildlife that are here. So this is the Nature Like Fishway, which was actually established in 2007 to help migrating river herring and other fish make their way up the Acushnet River to spawn. And since that time, you've seen an increase from about 300 fish heading up every year to over 10,000 in the spring of 2014. So in this section of the Acushnet Sawmill Park, we're reestablishing a red maple swamp. A red maple swamp is a type of wetland that really helps filter pollutants out of the water as it flows its way down to the Acushnet River. And what we've done here is we've actually excavated out part of the old concrete and sediment that was here and put red maples and cedar trees into place, and they'll grow up over time and eventually look like the natural swamp that exists behind us. This was part of the Acushnet sawmill's original use. They would actually put the lumber back here. Once the sawmill closed down, the trees grew up in their place. And these are red maples and other types of wetland trees that, again, help filter the water that flows its way down to the Acushnet River. So here we're on the north overlook, looking out over the Acushnet River as it's flowing south towards New Bedford Harbor. And this is a great example of a natural shoreline and bank and forest behind us. So the north overlook is also just a nice, peaceful, quiet spot to come and look for all sorts of different wildlife, especially birds. Migrating and native birds that are going to spend all their year here on the Acushnet River. So these construction trucks and equipment are almost done with their job, and they're part of the restoration here in the fall of 2014. After this, nature's going to take over, and the plants and the grasses and the vegetation that's been planted here is going to start to get established and grow, so that we're ready to open this site to the public in the spring of 2015.
These are wild fish that I'm going to be talking about now, and it's basically a story that's gone on for about 150 years. Now, Red Brook, if you're not familiar with it, is located between Miles Standish State Forest up in the northwest, and the Cape Cod Canal is down here. Red Brook flows for about 4 miles from White Island Pond to the north through the new Century Bog acquisition, the Red Brook Wildlife Management Area, and the Theodore Lyman Reserve before it empties into the Buttermilk Bay Estuary, which dumps out right by the Mass Maritime Academy in the Cape Cod Canal. Now, Red Brook, like most of the streams in this area, were formed by the glaciers. It was formed probably in what's called a spring sapping valley in the Wareham Outwash Plain. So these glacial deposits deposited a lot of sand and gravel, and over time, as the glaciers retreated, these channels were carved by the meltwater, and in these channels were formed groundwater streams like Red Brook. Now, another name for Red Brook, it's also known historically as Cohasset Creek or Ye Gravelly Brook, which gives you some idea of what the bottom of the stream must have looked like. But it's a cold water stream. It's fed almost entirely by groundwater, and it's slightly acidic in terms of water quality. Its natural origin is in a series of springs and seeps north of Route 25 now, and it's named for its natural iron deposits, hence the name Red. But those natural iron deposits also caused a lot of the destruction we saw on the Buzzards Bay streams, because people took advantage of this natural iron deposits, and they built foundries and nail factories and various things like that on these rivers. And they used the rivers to power a lot of these foundries and nail factories and things like that. But most of these streams supported our native trout species, the brook trout. It's not even a trout, it's actually a char. The Canadians actually call it by its proper name, which is the brook char. But the brook trout is a cold water species. It generally likes less than 70 degrees Fahrenheit temperatures, and its preferred temperatures are in the 52 to 56 degrees Fahrenheit range, which just about happens to be the temperature of groundwater in this area. The natural range of the brook trout ranges down from the Canadian Maritime provinces down along the Appalachians to about Georgia. And here in Buzzards Bay, we're kind of near the southern end of their coastal range. To give you a little idea of the life history of the brook trout actually seek out these areas of upwelling groundwater in October and November, and they actually sweep out the fine sediments and deposit their eggs in what are called redds, or nests. These eggs incubate in the gravel, being bathed by that constant temperature of the groundwater, and they generally hatch out in this area in late January or February. A typical brook trout in Massachusetts, this is what a young of year brook trout looks like in the fall. It's about 3 inches long at the end of its first year in life, about 6 inches at the second, and about 9 inches in its third year of life. And the brook trout is a very short-lived species. It really doesn't live much beyond 3 or 4 years. The changes in Red Brook happened early on. Red Brook was well known to the Native Americans. When the early settlers came down here, they found all kinds of oyster middens and shellfish middens at the lower reaches of Red Brook. So the Red Brook was known to the Native Americans, but the real changes in Red Brook started to occur back in the late 1700s and the 1800s, when a ditch was connected from the natural origin of Red Brook up into White Island Pond. And historically, the towns used to sell off the rights to herring fisheries. And so if you bid a certain amount of dollars to take the herring for bait or food out of that river, a good way to increase your profits was to open up greater spawning areas. So a lot of the herring runs in southeastern Massachusetts were actually created. They're man-made. A lot of these connections to these headwater ponds are not natural. And you can see that when I show some of the, well, you can see it on this map right here. Red Brook is the dividing line between Wareham and Plymouth. And right about in this area, which is below a gas pipeline right now, the town lines of Wareham and Plymouth go off at an angle. And to me, that indicates that the surveyors walked along the stream until they could no longer find a river channel, so they decided to go off at a straight angle. And that's, you can see this today in the land maps between Wareham and Plymouth. There's two species of river herring that inhabit Red Brook, the alewife and the blueback herring. Generally, the alewife come up earlier in the year and they migrate all the way up into White Island Pond, whereas the blueback spawn most often in Red Brook. They come up in the spring and then the juveniles go out in June and November. So the river herring do use Red Brook, but they're not permanent inhabitants. Now, Red Brook was also modified early on by the creation of one of the first cranberry bogs in the Buzzards Bay area in southeastern Mass off of Cape Cod. In the 1850s, the Crowell brothers of Sandwich built a bog near what was called Bartlett's Marsh Pond below White Island Pond. They took advantage of this channel from White Island Pond to get some of the water to help flood their cranberry bogs as well. But the real story of Red Brook begins with a man named Theodore Lyman. Theodore Lyman came back from the Civil War, and he was named one of the first commissioner of fisheries in the United States. The Commissioner of Fisheries of Inland Fisheries is the direct predecessor of my agency, the Division of Fisheries and Wildlife. We can trace it right back to Theodore Lyman. Theodore Lyman came back, and at that time the fisheries were so degraded in Massachusetts, they thought that fish culture was the answer to restore our brook trout populations. So Theodore Lyman was visiting his friend Samuel Tisdale, who happened to build a nail factory on the Agawam River, which used to be a brook trout stream. And while he was down there visiting this trout hatchery in Wareham, he discovered Red Brook. And he liked Red Brook so much that he started buying up the property in 1870. And the fish that attracted Theodore Lyman to Red Brook still occurs over 100 years later, and that's the salter brook trout. It's a life history variant of our native brook trout species. It gets its silver color because it's been down in the salt water. And I told you about how big the average brook trout is. You can see this is a lot bigger than the 9-inch brook trout that's a typical adult brook trout in Massachusetts. And in fact, there's a reason why they get so big. It's because they take advantage of the abundant resources of the estuary and salt water. And so they can grow to a very large size by taking advantage of the rich food resources of the salt water. And in April, they get this silvery sheen when they first come out of the salt water. You can tell they're very silvery like a salmon, but they lose this coloration within a couple of weeks of returning to the river. The Lyman family protected Red Brook for 6 generations. Over time, they bought more and more property when it became available along Red Brook, basically to preserve this as their hunting and fishing camp. The Lymans were basically a Boston Brahmin, a very well-to-do family, and they used to come down here and utilize Red Brook as their hunting and fishing escape. Around the 1980s, land development in Buzzards Bay and taxes started to go up. The Lymans started to get elderly, and they decided they wanted to pass on the legacy of Red Brook to Trout Unlimited. And so in 1988, they signed an agreement with Trout Unlimited that they would pass the property on to Trout Unlimited. Well, Trout Unlimited is not a land conservation agency, so it contacted a few other people to help them manage the property. But even when the Lymans owned the property, there was a history of cranberry growing in amongst the lower part of Red Brook. And the Lymans used to maintain these dams actually to create deeper water so they could cast their flies to catch the trout. It also served as catching areas for the herring fisheries that still occurred on these rivers back in the 20s and 30s. Around 1900, a man named LeBaron Barker purchased the Crowell Brothers bogs below White Island Pond and greatly expanded them and named them Century Bog in honor of the new century, 1900. These bogs were operated until about 1960 by the Barker family, and then they were purchased by A.D. Makepeace Company. And these are right near the headwaters of Red Brook. But a cranberry bog must do a lot of modifications to the habitat in order to profitably grow cranberries. They have to change the water levels, they have to change the flows, they have to periodically add sand to make the vines grow better, and they also have to use a variety of pesticides to keep the pests that will inhibit the cranberry crop. And so there's a lot of manipulation that occurs in order to grow cranberries on a natural stream. You have to establish a main bog ditch. That's where the main flow of water will come down. You have to build a series of pump houses in ponds to get your irrigation water for frost protection and to apply the pesticides. You have to establish a system of side and lateral ditches to keep a fairly level water level in the cranberry bogs to enable the cranberries to flourish. And you have to build a variety of flumes or small dams in order to control the water levels in these areas, as well as the roads and other infrastructure to enable you to get your equipment in to help grow cranberries. Even in the lower section, you can still see the remnants of these old cranberry dikes or dams. The Lymans, as I said, used to maintain these dams. They thought actually the water level, by boosting up some of the dams, they could actually create a better water level to enable them to fish better on these streams. And these flumes or cranberries basically were maintained by the Lyman family until about the 1990s. They actually used to put the boards in sometimes to increase the water flow. But these had a lot of negative impacts on the trout. The Lymans also tried to do some improvements. They built deflectors, trying to speed up the flow to scour away some of the sediment that was coming down from the cranberry bogs upstream and other factors. They also built this little barbed wire thing right at the head of tide to basically keep poachers away from their fish, which they were trying to protect. In the 1980s, the fishery had declined. They brought in a fisheries professor from Cornell University called Dwight Webster to look at the catch records. And one of the things that's unique about Red Brook, it's probably one of the most well-documented fisheries we have out there. The Lymans kept a diary of all the fish that they caught over the years. And Dwight Webster looked at these diaries and plotted some of it. And he noticed a pretty steep decline in the catch rates from the 1870s when Theodore Lyman was down here fishing up until the 1930s and 1950s. You can see some of the dips in the catches correspond to when the Lymans were away. The Europe was when Theodore Lyman went to Europe. He became a member of Congress later. Some of the Lymans went off to World War I and World War II. But one of the things that he did notice was a steep decline with the disappearance of the eelgrass. Back in the 1930s, a lot of our eelgrass beds were lost to a disease back in the 1930s. And so by the 1950s and 1960s, the Lymans were concerned about the fishery, and they actually started stocking the stream with hatchery brook trout and also introduced brown trout. And this continued the stocking up until about 1990, right about the time that I started. So in the 1988, Trout Unlimited knew they were getting this brook, but they're not land managers, so they contacted the trustees of reservations, one of the longest-term private conservation organizations in the country, as well as the Division of Fisheries and Wildlife. And in 2001, we signed a cooperative management agreement. The trustees of reservation took over the lower part of the property and established the Theodore Lyman Reserve. The Commonwealth of Mass purchased the 400 acres above Route 25, and that money was paid into a trust fund to help manage the property as a whole. And so we signed a cooperative management agreement between Trout Unlimited, Fisheries and Wildlife, and trustees of reservation to try to manage this fishery and protect it for future generations. And we established quite a few different goals to try to improve the brook trout populations. One of the things that we noticed was these cranberry bog flumes in the lower part basically were probably detrimental to the fishery. Whenever you put a flume or a dam into a river, you trap sediment that Sara mentioned. And you can see actually here some sand deposits in back of one of these small flumes. And so one of the things that we wanted to do was improve fish passage and also improve the sediment flow throughout the river. So we decided to take out a series of these small flumes from Robbins at the top down to the lower flumes and improve the Sandwich Road crossing, which is basically at the head of tide. If you look at a lot of maps, you'll find these old historic roads, and they basically oftentimes went over an area of rapids right at the head of tide. And that's historically where a rapids probably was at the Sandwich Road crossing. So after many years of discussion, several years of permitting, we were able to remove the first flume in 2006. With all of these projects, it takes years of permitting, and then the actual construction takes a day or two. It's kind of frustrating and amazing how long things actually take in terms of restoration. In 2008, we took out another flume. We built up the bank with some of this cocoa reed mat or fiber matting and planted trees. And you can see on the corner there what it looked like after we planted the trees. So we basically removed the flume, narrowed up the channel, and improved the water flow. But the big events happened in 2009 when we removed those, what was called the big flume, the little flume, and side flumes. These were actually later built up to concrete. We pulled those out and reestablished the banks. We also cut down the levees on the side of the bank, similar to what was done in the Acushnet River, where they cut down the concrete or the granite block retaining walls. We basically just had to dig back the earth, rebuild the banks, and plant some trees. But one of the key things that we did here was to restore wood. Naturally, these streams had centuries of old wood in them, which offered great habitat for fish. In fact, there's a picture of a brook trout hiding out under some wood structure in Red Brook. So it's very important to put the wood back into the river. And this is an example of what the area looks like at Red Brook with a completed woody structure addition. And over time, more and more wood will start to enter the river and provide habitat for trout and other fish. At about this time, there was also some technology developed. Actually, I can thank Brendan Annette, who's in the audience, for starting this project with the pit tagging, which actually started over in the Acushnet River. Since Brendan started the project back in 2007 in the Acushnet River, we've greatly expanded our pit tagging on these coastal brook trout streams, and we've learned quite a bit. And these little tags are similar to the anti-theft technology in stores or the fast pass that you have on Mass Pike. It's a radio transponder, and you can inject these into the fish. They're basically a miniature chip with a little antenna. And we put up 2 antennas on Red Brook in 2008 on either side of those concrete flumes. At the time, we hoped to see improvements in fish passage, but I'll show you some of the things why we didn't exactly figure that out, because there wasn't a lot of movement, because we basically put it in like November 5th of 2008, which you'll see in a reason why. It's like they move quite a bit at certain times of the year. So the way this works, the fish with the tag swims through these PVC antennas that have a wire in it. The fish swims through, the tag gets energized, it beeps out a radio signal, and that gets beeped into what's called a receiver, and that gives me the tag number, the date, and the time that the fish went through that antenna. And if you look closely, I don't know if you can see it here, but where this antenna is a big sand deposit. So in 2008, where I put that antenna, it was entirely a sand bed. Now, we've been doing this since 2008. We've got tens of 65,000 detections, I think. We've tagged over 2,000 fish. And one of the things that we found is most of the movement in this stream occurs in the fall associated with spawning. They're seeking out these very confined areas of groundwater upwelling in order to deposit their eggs. We also found out that they move most often at night hours. They don't move as much during the day. And I can tell you why, because a lot of the big fish that we have often have bird strike wounds on them. So it's tough being a big fish in a small river when you have a lot of birds around. And so they've kind of adapted to this, and they do most of their movements outside the daylight hours. Now, if you're really good at an ink blot test, you can see what I mean from this antenna. This is kind of lumped all the years together. These vertical lines here indicate a lot of movement during November. And if you look closely, you can see almost like these half-moon shapes. It's basically right around sunrise and sunset seems to be when they move quite a bit.
They don't move as much during the middle of the day, except predominantly in the fall when they're associated with the spawning. So like I say, I've got a lot of data from multiple rivers that I'm just in the process of trying to analyze it all now. But if this gives you some indication of what happened after we removed those big flumes. This was taken in November during the spawning. If you look closely, you'll see some movement. That's the female digging out her red right above the antenna. I came up to the antenna, I ran out of memory. There was over 4,500 hits on this antenna in 1 week. And the reason was there was a lot of spawning activity right there. And so you can see the fish moving around. They're very active at this time of the year. But this was very heartening to see this, because the reason why they were spawning right here was a direct result of that flume removal. Basically, when we removed that flume, this area became great spawning habitat. It increased the flow, it scoured out some of the sand, and it allowed the natural groundwater to upwell into this gravel area. And so these fish took advantage of it. And if you can see it here, these are the brook trout spawning right there. And this is one of the few times of the year where you can actually see the brook trout in the streams. They're very intent on spawning. I was basically looking down over the edge at them. And that's about the only time you can really see the brook trout in these streams. But one of the big questions that we had was, do these fish actually go down into the salt water still? The salt or brook trout, are they really salt or brook trout? And so we got some people from UMass and the U.S. Geological Survey interested that happen to have some receivers. And we were able to purchase some tags with the help of different funding sources. And we implanted a total of 84 fish with these tags. And the woman down in the corner is Erin Snook, who actually got her master's thesis on this study. There was about a total of 14 receivers that were put throughout the river and into Buttermilk Bay. In fact, one of them was down near the Mass Maritime Academy. On the very bottom, you can see the Cape Cod Canal. Now, if you were brook trout, you used to call this the Monument River. There used to be brook trout in the Cape Cod Canal when it was a river. But when they put the canal in 1914, they basically destroyed that river. So out of the 84 that were acoustic tagged, about 60 of them had valid detections. 12 of them actually went all the way up to the bottom of Century Bog, which kind of surprised us. And almost half of them were detected down in the lower estuary, in those tidal areas. And 8 of them actually swam out into Buttermilk Bay itself, and this was like the first documentation of these sea-run brook trout actually doing this behavior down in the United States. And so this was some great information. But one of the things that we found out is, 8 of them did go out into Buttermilk Bay, but only 2 of them returned. So that kind of gives you a hint that something's out in the bay that's not allowing for these survival. And so, like most research, the more research you do, the more questions develop from it. And so that's one of the things that we have to look at in the future is, how can we improve that survival out in the bay itself? Now, the good thing about the acoustic tags, it helped fill in some of the gaps. This is a depiction of movement of a fish that we called the devilfish, because its acoustic tag had the last numbers of 666. We usually don't name our fish. We usually give them numbers, but this one we do call the devilfish. We actually recaptured this multiple times, and this was one of the few fish that actually made it out into the bay and returned. And one of the reasons it probably returned, because it was only out in Buttermilk Bay itself for about a day or so. It spent a lot of time in the tidal areas of Red Brook, but not a lot out in the bay itself. One of the things that we had always hoped for in Red Brook, and we had always talked about, was the impact of the upstream bogs on the lower Red Brook. You basically have to do these fall floods, and they'd have these big floods of water come down in the fall when the brook trout were spawning, or the eggs were in their reds when they were trying to release their flood water after the winter flood. And the AD Makepeace Company had been very good partners with us in removing the flumes. They actually provided a lot of the manpower and the materials to remove these flumes in the lower part. And in 2010, we were able to make an agreement, the Commonwealth, with the AD Makepeace Company to purchase the bogs. We allowed them to grow cranberries under a lease agreement for 5 years. But we actually purchased the property in 2010. And so this past year was the last year that they actually harvested cranberries from Century Bog. We developed a design trying to improve the habitat of century bog to help protect Red Brook. It's going to have a passage for the alewives to continue to get up into White Island Pond. If it was all about the trout, we'd probably just close off the entrance into White Island Pond. But the herring are very important for a lot of the wildlife and fisheries of the Buzzards Bay. So we want to maintain that herring run. But we also want to reduce the water temperature to Red Brook and create a mosaic of wetland habitats up in the cranberry bog, basically convert it from a monoculture to a variety of self-sustaining wetland habitats. And one of the reasons we need to do something up at Century Bog is the stream temperatures. We have a bunch of temperature monitors throughout Red Brook, and the temperatures right now in Century Bog get up to about 75 degrees average in some Julys. So I mentioned that 70-degree mark as being critical for brook trout. Right now, the brook trout habitat is not found in Century Bog during the summer, and hopefully we'll be able to moderate those temperatures, which will also improve the amount of habitat in Lower Red Brook. And to do this, we're basically going to simplify the channel. We're going to shrink 11 miles of bog ditch down to 1 mile of stream to provide a fish passageway through Century Bog from Lower Red Brook up into White Island Pond for the herring. We're going to remove the sand cap as much as possible to expose that peat and to reduce the height above groundwater. If we just abandon these bogs, they're going to grow up to pitch pines, and we want to create a mosaic of wetland habitats. And what we don't want to do is to back the water up like they've done on other restoration projects, which can create very high water temperatures. And so we're very careful that we want to keep moderate water temperatures here at Century Bog during the restoration. And one of the things that we're going to try to do at Century Bog that we found is there's always a natural seed bank within the wetland habitat of that cranberry bog. And so if we can just disturb the soil, we can allow a lot of that natural regeneration to occur. We'll still have to do some invasive species control, but we're going to rely primarily on the natural seed bank. I mentioned, some of the research we did raised some questions. Well, this picture in here is a picture of Buttermilk Bay, and those green spots were eelgrass beds were mapped in 1995. If you look at the recent reports, there are no eelgrass beds like that in Buttermilk Bay. And Dwight Webster's report kind of linked that to some of the decline in the sea-run brook trout of Red Brook. And based on our acoustic tagging data, this might have a lot to do with it. When you don't have eelgrass beds out in the bay, you don't have a lot of hiding cover for these brook trout when they drop down into the ocean in the winter after the spawn. So one of the things they asked us is, what can you do to help restore brook trout and other species to Buzzards Bay? Well, the primary thing is you have to support organizations, advocacy organizations like the Buzzards Bay Coalition, the Sea Run Brook Trout Coalition, and Trout Unlimited, as they try to fight for these projects and fight and get funding and allow these projects to go through the permitting process. As I'll mention about how many people are actually involved in this, and if there are restoration projects in your area, you need to support them, and also land protection. I mean, protecting the land is the key. Without protection of the land, you can't protect a lot of the habitats. The reason why I'm talking about Red Brook here today is because Theodore Lyman bought up some of that property back in the 1870s. His son actually did a video, which you can get on Theodore Lyman, and his son asked me on camera, it's like, what could Theodore Lyman have done different to help protect Red Brook? And my answer as I looked up from the brook over at a densely packed neighborhood in Plymouth was, he should have bought more land back when it was cheap. But we can also reduce our impact, reduce our fertilizer, reduce our water use. I mentioned a lot of, right now there's onset wells, which are on the side of Red Brook, which are basically taking some of the groundwater that probably went into Red Brook. So whenever you're using water, basically you're taking it out of the groundwater, which feeds a lot of these streams. You also need to support the development of sewers and other nutrient controls. One of the common threads that we've heard in all these presentations is the impact of sewage and nutrients. A lot of these things, the reasons why the eelgrass beds are not there is nitrogen. The algae basically shade out the eelgrass beds. And so if we're really going to restore our environment and restore these habitats, we have to control our impact on the land. And we need to do that by controlling our nutrients. As I mentioned, the big thing these days is coalitions, cooperators. You can't do everything yourself. I've discovered that a lot in my career. I've been doing this for 25 years. I've been working on some of these projects for 25 years. And I rely on a variety of people to actually get things done. One of the primary ones that helped our Red Brook, besides our cooperators, trustees of reservations, and Trout Unlimited, was the Division of Ecological Restoration in the Department of Fish and Game. They actually did a lot of the work of permitting and getting it done. We got funding from A.D. Makepeace Company. We got funding from American Rivers. A lot of people were involved in Red Brook, and that's going to be the future, is actually building these coalitions to help get restoration done. So at this point, I'd be glad to answer any questions, or maybe we could save that for the panel discussion. But thanks for listening.
So just a few questions. One of the things that I think really interests us all, or it's so great to hear stories of positive change, and we want to see more of it. And I want to ask you about what you guys have lined up, sort of what's next in your sites. Steve, you mentioned Westport as a place where there's potential for some real work to be done in terms of stream habitat and for trout, which people don't know about.
Right. One of the reasons I'm talking about Red Brook, it's one of the few remaining brook trout fisheries that we have in southeastern Massachusetts. I've been spending a lot of my time on protecting these native fisheries. Here in Buzzards Bay, we have a couple tiny brook trout streams that feed in Falmouth to the eastern edge of Buzzards Bay. There's Red Brook. There's a couple little streams at the headwaters of the Monkinko River. And then there's Westport. Westport's kind of this unique place where almost every little stream there still has some brook trout. And the reason for that is because Westport is still pretty rural, which is kind of amazing that it's in between the cities of New Bedford and Fall River, and it's still this like rural enclave that reminds me of New Hampshire. You still have stone walls and you still have trout streams. But the trouble is Westport is starting to be developed, and I believe that these brook trout streams are one of our most endangered brook trout fisheries that we have remaining out there.
So what's, how do you promote that? Land protection, and what's the next step to make that?
In my mind, land protection is the key. Without protecting the land, you really can't protect the fishery. So I know the Trustees of Reservation, the Coalition for Buzzards Bay, and other groups have been purchasing land, basically purchasing some of this farmland that abuts these streams and help protecting it for the future. So right now, land conservation is the key in Westport. We don't have to do a lot of these dam removals that we do in other areas. There has been some proposals to recreate some of these old mill dams, which we have to be concerned about. But I think the principal thing there is conserving and protecting the land, either through purchase or conservation restrictions.
And Sara, if you could just talk a little bit about the other projects that restoration projects the coalition is working on, and maybe also give a little more detail about what's ahead for potentially what's ahead for New Bedford. You showed that map, but maybe if you could just talk a little bit about what's on the horizon.
Sure. I'll start off with the New Bedford one first. The one other restoration project that's sort of in the works in New Bedford Harbor. Is this working okay? There we go. Better. Marsh Island is a 12-acre salt marsh restoration project that the coalition is involved in that will restore some of those filled wetlands that I referred to. Marsh Island, it's not really an island anymore. Now it's more of like a peninsula because it had been really heavily mined for the granite that was actually used to build some of the bridges that cross the Acushnet River. And then a lot of the dredged material from Bedford Harbor filled it back in again. And as a result, the marsh habitat that was on this significant area of land in the harbor, those were lost. And so we're working with, again, several partners with funding through the New Bedford Harbor Trustee Council to restore those habitats that would provide more nursery area for the small fish that support our local fisheries. Along the lines of river restoration, more similar to the sawmill, we're also looking at a similar project over in Wareham on the Weweantic River. Very similar in the sense that it's another property that the coalition protected with multiple partners, and we own another dam at the head of tide on the Weweantic, and it's the most dam on the river that similarly impacts fish. So we've done some initial base mapping and collected some initial data, but sort of the next big steps for us are getting some more funding in place to really hone in and get a feasibility study done that will help us figure out what the best approach for restoring fish passage will be at Horseshoe Mill Dam, which is the dam that sits on that Weweantic property.
Do you have a time frame on that, or it's just whenever you can get the funding, or what's the variable which is guiding this?
We're hoping to have a feasibility assessment pulled together by the end of the year. Hoping. Funding dependent.
And John, couple questions come to mind. One is not so much about the future, but I was curious as to, you said the substrate had changed for the oysters, and what caused that? It was hard before, and now what's on the bottom now, and how do you get around that?
Yeah, good question. And Steve alluded to this a little bit by talking about sediment that's come downstream. So certainly some of it is sediment based on our land use practices over time. Maybe not so good practices in terms of actually sediment. People don't realize is a major pollutant in terms of uncontrolled sediment and getting into the system. Part of it is that, and it flushes down our rivers and into our embayments. We're also getting conditions of anoxic muds that become softer and more soupy, this black muck for people who may be out in the mud flats, very sulfury smelling, and that's just in terms of indicative of not an unhealthy system. We see it in very urbanized areas and areas that are just not productive.
And so how will you be able to keep your oysters alive under those kind of conditions?
Yeah, one way is to avoid that sort of condition, but by creating oyster reefs around Buzzards Bay, it is contributing to filtering water. Oysters also filter sediment, so they're actually improving what we call the residence time. That's how long it takes water to get through a system, and clarifying it, including the sediment and controlling muck as well.
And what are your results for Wellfleet and the vineyard? What are you seeing so far?
Yeah, Wellfleet was a very successful story because they have a lot of spat in the water, wild juveniles that settled. The issue with a restoration like that, it was in an intertidal area, and the project's actually gone. It's buried by sand. It was a very small demonstration. And we know that oyster reefs can be ephemeral that way and move around. For some reason, there was historically a reef there, and it didn't get established enough to stay. We've done work in Tisbury Great Pond. Our monitoring is showing that the acre we put there has increasing amount of wild oysters on it. We try to get 50 live oysters per square meter, which is what we see in natural beds. We're not quite there yet, but in that site, we're seeing pretty good productivity.
And I think you said there was 4 more sites that you're going to be planting oysters. Where would those be?
Yeah, we're planning at least 4 more sites over the next 4 years in Buzzards Bay. I say that because it depends on how far the money will go. We've been conservative, so we at least get 4 done. Usually the way restoration works, whether it's removing dams or fish passage or oysters or whatever it might be, it takes twice as long. So our 4-year effort will probably result in 8 years, and I hope we'll do 8 or more projects in that.
And do you guys have anything to add to Steve's list about how we can help you bring these projects to fruition, either politically or financially or in other ways?
Advocacy is huge, and Steve hit the nail on the head with just speaking out about how important these projects are to you, making sure that that is known to the municipalities, to the selectmen in your town, to the conservation commissions, and let them know that, with restoration, yes, comes change, but the reason why we're proposing this change is because it's for the better. It's to improve resources that have been severely impacted over the past decades, and we have a chance to bring those back, but we can't do it unless we're willing to sort of take a little bit of that risk to see the landscape change maybe a little bit more than how we've been seeing it the past few years. That's probably one of the, aside from funding, is that's one of the biggest hurdles, is getting people to accept the fact that restoration does involve some changes on the landscape that are not always, we're not always willing to let that go freely. So that's the biggest.
Anything to add?
One thing I'll add, Sara said that very eloquently. I'm not sure I could say it any better. All true and really good ways to help. But one thing we're trying to get much better at, the Nature Conservancy is doing this, many organizations are doing it, and that's trying to figure out the cost benefit of having healthy ecosystems and you know, what the alternative is in terms of having rivers or shellfish beds that aren't healthy. What's the cost to us in trying to quantify that? So that's something we're trying to learn more about. We need funding and support to do that, but it's critically important when we make decisions at the town or state level, because that's really how we make decisions, is what's the cost and what's the bang for the buck. We haven't been very good about quantifying the benefits of functioning salt marshes, eelgrass meadows, brook trout populations, whatever it might be. So that's something we need support and are trying to do. And I think we're collectively doing a better job.
Great, thanks. I'd like to open it up to questions now. So we have some microphones here, or if you want to just stand up and yell, that'd be great.
Just for the commercial oyster beds in Wellfleet near Tennant's Island, what's the impact of those on that whole ecosystem?
Yeah, this is a tricky question because when we think about oysters, or really many shellfish, but oysters in particular, true wild oysters are difficult to find because we've been farming them for hundreds of years, essentially. So, you know, there's all sorts of ways to grow shellfish. We're now doing it in cages because it's more productive. You get a better product. It gets cupped. It doesn't have sand in it. You know, it's what we like to eat. But there's also a lot of bottom culture that is somewhere in between wild and harvested, and the value of that is somewhere in between a wild bed that you didn't regularly harvest, because every time you're disturbing the bed, you're taking away those ecological benefits. You're removing the value of all the services it provides to some degree. So it's always present at a minimal level, but depending on the level of disturbance, that really dictates how much return you get. So when we're restoring areas, we're trying to use those as a spawner area for the town to manage their supply of shellfish so that they can fish other areas and realize there's value in keeping some areas off limits. And there's some rules about how long you can do that and how you do that and trying to figure that out. But it's a complicated question. It's a very good one.
A quick question. It seems that one of the problems with restoration or funding land preservation is that for the public, out of sight is out of mind. And of the residents of the watershed area, the percentage who actually make it out onto the bays or up and down the estuaries is probably a very small percentage of the total number of people living here. In the East River, alongside Manhattan, the New York Harbor School is engaged in the Billion Oyster Project that you're probably very familiar with. And they've partnered with high-end New York restaurants that serve oysters. And it's the net result is there's a lot of publicity of having young people out in their future habitat helping to preserve it. And I just wonder, John, in your vision of this area, is there any way to get young faces out there doing work? Because currently, if you have professionals funded by people who live along the water or near the water, the message doesn't get out in a compelling way to voters and policymakers who may not have that same view.
Yeah, really good example with the billion oysters in New York City, which really was the mother lode of oysters on the East Coast for people who aren't familiar. It was so full of oysters they had to dredge them out of the way to get ships in. We are including in our projects an outreach component. We're really relying on the Buzzards Bay Coalition. The Conservancy doesn't have a lot of capacity. We have, however, just hired a volunteer coordinator. I think we'll get better at this. But your question's a good one, and that project is a really good example. Maybe we could do 1 billion oysters in Buzzards Bay and build some momentum. And it did start with kids and a school who did that. So we have a lot to learn and a long way to go, but we will be including that in our projects as we move along.
Hi, Sara. You mentioned the canoe launch ramp at the Acushnet sawmill site, and I wondered whether it was going to be possible to canoe upstream all the way to Hamlin Street.
That's the goal. I know a couple of folks who have done it without the benefit of having a nice, easy spot to put in a canoe or kayak. But by putting in this launch, yes, the goal is that pending any low-hanging branches that we might have to contend with and the water levels that we know will fluctuate throughout the year, that, yes, we'll be able to put in kayaks and canoes and explore the river like we really haven't been able to before.